So I've made a couple of changes here I wanted to show you, and before I get into the rest of the build, I cut this piece off from the piece of channel aluminum there. So just make it. First of all, this extra piece sticking out didn't serve any purpose, and second of all, it made it a little more difficult to load or change belts. So I just cut that off back to basically to the end of the column. Also, I cut the bottom part of this U-channel off. So basically, if you're going to build this thing, you could just use a piece of angle iron or angle aluminum. Again, that extra width on the bottom was simply adding to the height, which I didn't care for, and it didn't serve any useful purpose. The plywood top, 1/2-inch plywood, is fastened with these 4 screws. The piece of angle is fastened under that. Also makes getting access to this screw here easier to tighten up the column. This is the tracking adjustment view from the bottom. You can see as this screw goes in and out, there's a little bit of lateral movement there. I've just got a small spring. This is a 6x32 threaded rod. That size isn't critical. 8x32 would probably work just fine. 10x32 is going to be a little too big, I think. You have to keep in mind that this is pretty close to the bottom of the top there, and you need some tolerance or some clearance there for the spring and the sleeve. This is just a spring. Again, that spring could go all the way out to the edge if you wanted to. I just happen to have this little shorter spring on hand, so I used an aluminum sleeve to extend the length out there. Then washers in this size tend to be too big around, so I just drilled out a 632 screw or nut so that it would slide up and down on that thread. Then this, you can see I've got a slot. This is the side. I've got a slot on the side there that goes over that, and so this whole thing fits on there like that. So now then you can use this screw adjustment to pull in the the threaded rod, or push it back, which causes the column to rotate. Here you can see it from the top. Let me take this off here so you can see what I did on this column. I bent that down at an angle so that this is bent down at an angle so that it extends down below the top for that simple aluminum hinge piece there to fasten. Here you can see the hole for the threaded rod. This is a 632 screw that's also driven down through the top into the aluminum. Now, probably going to have to put a little dab of Loctite on this thing, because I can see it's probably going to rotate and either work its way loose or tighten it down, making it too hard to work. Stick this back in here real quick. Allow yourself plenty of thread through there so that it doesn't fall out on you. So then again, this side just goes on here and provides a stop for that screw on the inside. Then you'll put a knob on the outside here, which I haven't made that yet, but I will. And that knob has to bear against this wood so it can pull that column out when you're adjusting it. So here we have the finished product. I've got it plugged in over here behind. You can't see. I've got it plugged into a variable DC power supply that goes from 0 to 120 volts. This motor is rated at 12 volts, so that's all I will crank it up to. You can see this little knob here. I have the luxury of owning a metal lathe in my shop, so I made that little knob out of a piece of 1211L let's see, 12L14 leaded steel. Could be made out of anything, brass, aluminum, or perhaps you can fabricate something. It's threaded onto that 632 rod, and then I put a set screw in the side just to hold it, because I don't want this turning on the rod. I want the rod to turn inside that block back there. But you can see, hopefully it's in focus, you can see here that it moves. It rotates the column around as you turn it. And I'll show you that it works. That's about half speed. So you see as I turn the knob, the belt does adjust nicely from one side to the other. And I doubt it'll need adjustment very much. It's kind of been my experience with these belt sanders that once you get the tracking set up, if it's reasonably solid, it'll stay there. It's a little loud at 12 volts, but I'm going to turn it up. That's probably a little over 12 volts. You see, it does cut pretty aggressively at that speed, but you can throttle it back if you want to do some fine work and just take things very slowly and get a nice finish. It still sands plenty well at those lower speeds. You know, a little bit bigger motor might have been good, but you can compensate for it by the, you know, with the variable DC adjustment. There you can see the underneath side. By the way, neither one of these columns or these pulleys is crowned. They're both flat, but the pulley on top, as you may recall, is a half-inch bearing. So that probably is what tends to keep this in the center. Changing belts is easy. You just press down on that tab a little bit, slide the old belt off, slides completely out. It's easier to put it on the bottom first and then put it on the top. Make sure it's completely on the pulley down there and start it up. Here's a piece of aluminum. See, it sands. It takes it off okay. It's a little bit slow, but like I said, you can overrun these motors for short periods of time, and they're not going to overheat. You could probably run that at 15, 16 volts for a while, or maybe even higher than that, and it's not going to overheat. So I think that's pretty much it. I drilled a few extra holes in here. I tend to overdo things. I decided at the end of the day that 4 screws in there was more than enough. Those are just 1.25 inch long drywall screws. Same here. I had drilled 6 holes for fastening this piece of metal to the top. 4 holes was plenty. 2 probably would have been plenty, but you know, 4's better. I have to fasten these wires onto the motor more permanently, and I'll put a switch on it so that I can turn it off and on without just plugging it in. But I think that's it, other than maybe putting a finish on the wood so it doesn't get all dirty. Thanks for watching.